I'm Rahul Padigela. I'm the Director of Engineering at Scality. My topic is going to be a segue from like what Nicola presented, what Paul has been presenting. So we we have presented about Zenko. You have seen our website, marketing, and everything. We always talk about freedom and control and how we do this across different cloud environments. Our Zenko had ton of it has a vast amount of features, can unlock a ton of use cases, but it always required we need the metadata to be able to do this thing. Like you have to put Zenko in the middle. You ingest or you write through Zenko, and you can write it to any. You can write to private clouds. You can write to public clouds. You can write to Ring. You can do metadata search. You can set up lifecycle policies. You can do all these kind of things. But then we still had this requirement like, how can we give even more freedom for our customers? And this is the feature that was born out of it. We have had a lot of customers ask for use cases like, okay, cool, we have everything running, it's pristine, Zenko is running in our data center, or sometimes it's running in the cloud, but we have users who kind of work on the same namespace, and some of them are located on East Coast, some of them are like completely siloed in a private data center, and some of them are located on West Coast. Like, how can we share the namespace without like having without stepping over each other? I'm like, okay, let's think about it, and we came up with the idea of using eventually consistent views. So it's what use cases it unlocks, what eventually consistent views is about is that we have to let applications write to the storage wherever wherever they can be, and they should be able to access them natively without going through Zenko. Just because you wrote through Zenko doesn't mean you have to use Zenko to access those objects, and just because you sidestepped Zenko and you went directly to the public cloud and you wrote objects in the public cloud, they're no longer available in Zenko. So that's what eventually consistent views brings together. You can write on anywhere, but once you come to Zenko, you have a single namespace that shows all the objects, all the buckets that you've been working on. It unlocks your disaster recovery, any fail or failback use cases. You have objects written on AWS, and you want to perform metadata search on them with the objects combined that are written on your on your Ring at the same time. This eventually consistent view can help you with that, and any migration. One of the recent deployments that I can think about is one of our customers. They have a Ring to which like they work on a lot of R&D, ton of big files. They need these files to be available on AWS for disaster recovery purposes, but they also want a failover scenario where if and when they lose the connectivity to the data center, they don't want any disruption to their application. So they want to be able to fail out immediately to Amazon, write objects out there, and then when the data center comes back up, they want to fail back and then keep writing as nothing happened. And we would magically somehow make objects available in the same namespace when this happens. So how did we do this? And I want to talk a little bit on the architecture. So it's the obvious thing that you can go for is like, okay, cool, we're going to go list the objects on the bucket using the APIs. We can easily scale by copying metadata by performing head request. You list objects in a bucket, you can perform a head request to fetch metadata. But we quickly ran into a ton of scalability issues. Like, this is super cool. Like it's super fast. We can integrate a ton of public cloud vendors, but it does have like limitations. And one of the main couple of limitations, then I've listed a few of them here, but listing a bucket is relatively slow. Like, that's the slowest API you can access an object storage. Everything else is super fast, like heads, pods, gets, deletes, like everything's super fast. But if you try to do a listing, it's gonna be slow, especially if you have like billions of objects. It takes a couple of hours, depending on the storage system. It may take even a day to crawl the entire namespace. You can't even like guess the namespace. You cannot. You get like 1,000 objects, but you don't know what the next 1,000 objects are. Where to intelligently like prepare yourself to copy metadata fastly. Like so, it doesn't offer you much room to scale, and scanning the entire namespace also limits the number of times you can fetch the number of updates. So that, as I said, like you can get 1,000 objects in a listing. So you at the best you can perform 1,000 head requests at the same time. But we are again like dealing with public clouds. You may have connectivity problems. Uh, you may get intermittent 500s where you need a retrying backup mechanism. You also may be throttled. So there are a ton of issues that you immediately run into. So how we fix this is essentially what we call as a deep integration. The first time the bucket is added to Zenko, we do a one-time listing. It's like kind of take a snapshot of the bucket, and then we leverage the power of serverless apps like AWS SNS to get notified any updates. Like bucket can be on AWS specifically, like a bucket can be set up with notifications, and you can set AWS Lambda as a destination to fetch object metadata, and you can write this to an SNS topic, and you as an application can consume super fast. It's near real-time updates. You're not crawling a huge namespace by listing, and it's super fast. So, and that works for AWS, but like how does this play out for different cloud storage vendors? So we found a lot of parallels across the three main cloud storage vendors that we use today, that a lot of our customers use today. AWS has list objects using S3 API. So does Azure has a list of using the Blob Storage API. Google Cloud Storage has its own Cloud Storage API to list objects. AWS has Lambda. Azure has Azure functions. Google Cloud has Cloud functions. There's SNS, when grid, Cloud pops up. Like, so we were able to like homogenize an architecture that we can apply to different public clouds and essentially offer a seamless integration of namespace.
About these other components that now are building the entire namespace, and you're solving the consistency and listing issues. Those extra components. So every file that gets written, you get Lambda and SNS operations, for example. That could turn into like millions of them. Where does their cost come from? So is it built in, baked into the costing of it? How does that work?
It's a minimal. So we try to the way Cloud Functions or Lambda charge users is by the amount of data you access and how much data is transferred. What we usually do is we take a handful of updates. So every head request comes with at the most 2 kilobytes, and Lambda limitations are in the matter of megabytes. So you can actually pack 10 to 20 head object requests in a function to reduce the cost and apply to a SNS notification. We have seen, honestly, like at customers, we have seen, so this is still in the works, and we are working with different customers to understand how they want to approach it. We have different strategies. Like one is that like a few customers, they are like, hey, at the best, the cost is going to be like $1,200 to $1,500 for our applications usage. So that's a cost we can absorb, and that should be fine for us. The other ones we have seen while we were looking at other applications, we show some of the things like we could do is marketplace applications, and marketplace applications would charge either the customer, or we can just charge Scality for that. So we still have to figure out the billing part of it, but it's a very small amount we're talking about. So this is AWS, their browser. I created my bucket in the US East 1 region, Rahul Cloud Field Day. It has versioning enabled, and this is our Orbit portal. It has Zenko running in a data center, and this is just an online portal that shows you different the use case, the usage, any configuration that you want, any workflows you want to set up, you can do it through here. We also have sandboxes available on Orbit if you do want to give it a try. How to perform replication, how to add different locations, like everything's available online. What I have done here is I set up my bucket here as a location. Location would mean that it uses my credentials. It has the target bucket where I'm expecting the data to come from. The only thing it checks is that if versioning is enabled, because we are talking about eventually consistent views, it's easy for anyone to write objects with the same name and step over each other. So versioning allows you to not do that. So you can create multiple archival versions if you do ever want to revert and say like, okay, no, this is not the latest version. I want to use this as the latest version. You can still do that. And I set up mirroring from that AWS S3 bucket to my Zenko bucket. And let me try to upload a few objects. I took the liberty of grabbing all of you guys' pictures from LinkedIn. Thought that would be a really good demo. You can upload them here. And it's uploaded. So in the background, what we have is we have an asynchronous job that reads these buckets every minute. So what you're seeing right now is a nominal integration. In the background, this job runs. It does listing and it does the head objects from the list from the objects it got from the listing, and they should show up any minute now. There what's in objects. Okay. Set here. The objects are all here. And here they are. Let me try to download. Let's try Enrico's image. You could probably not see it because my screen switched over, but so essentially what happened here is that I was describing, like it performed listing on the bucket. It did head objects. It copied all the metadata, including system metadata that's available on the object, into the bucket. The data is not copied. The data actually still sits on AWS S3. All we are seeing is metadata, and when you click download, it goes to Amazon and it fetches it. But what this unlocks is that like all the features we have in Zenko, you can do multi-cloud search. You can now set up replication from this bucket to Google Cloud if you want. You can bring the data to on-premise to Ring if you want. You can set up a life cycle where you tier data after a certain time to a different bucket on AWS, different cloud provider altogether. You can expire things if you want. So there are a ton of cool features you unlock by doing this. If you have any questions, I think I have some time, but yeah.
I do have one question, just based on the last slide of that demo. There was a replication tab. Can you set up some type of event service that it would detect when new objects were put in one particular bucket, we'll say, and then trigger a replication event to make sure it gets spread out to multiple cloud storage providers?
Yes, you can. So so right now, what my bucket is backed up by an Amazon S3 bucket. So right after you set up the mirroring or the eventually consistent view, you copy the metadata. You set up the replication workflow. Zenko offers one-to-many replication, as in like we can replicate to multiple clouds at the same time. So you can set up the workflow, and it would copy the data from, as I said, like from Amazon to, if you wanted to go to Google Cloud, Azure, if you want to go to on-prem at the same time, you can set up that workflow. Yes.
With the ability to now have those views and that rich set of metadata in the software, does it allow? Or I guess where is the extensibility points? Can I actually write applications now that can consume and write custom metadata into your application that still stores the buckets in S3 Azure or wherever, so I can kind of unify how I deal with the large blob data?
Yeah. So the our interface is S3 API. And since the objects are connected to AWS, if you write any user metadata, so user metadata has to be written when the object is being created. So if you write any new user metadata, it would create a new version on AWS. But tags are mutable on an object, so you can add additional tags. You can do that via Zenko, and that will show up on AWS as natively object tags. And it's the same thing, like if you go to the Amazon S3 directly in the bucket and you put any tags or any user metadata in there, it will automatically show up in Zenko. So you can do either way, but you can still use Zenko as just like one place where you have everything.
What about custom metadata? If I wanted to have custom types of data I'm putting on that's more than just tags.
Mm-hmm. So custom metadata is on the API semantics. Objects on AWS, objects are immutable, so you cannot change the metadata of an object or by adding new metadata. It will always create a new version for you. So if you are okay with Amazon creating a new version, so you can add new custom metadata. It will be ingested as a new object. Either if you do it on Zenko, it will show up as new object version on AWS. And if you do that on AWS, it will show up on Zenko. It will be the master version. So when you list, you'll always see the new user metadata that you have added.
Cool, thanks.
A quick question is that on the update mechanisms, again, going back to that in terms of, so if the operation is very fast, so for example, you're writing thousands of files a second or something like that to the environment, is the system able to cope with that kind of update cadence?
It can if we leverage the deep integration we have. So the normal integration, that's the part where we will run into scalability issues because you're expanding the namespace now. It's going to take longer for the application to list objects in the bucket, which means you will start diverging at one point. Especially if you're writing like super small objects and you're doing like tons of operations per second. With the deep integration though, since the updates are real time, we're not scanning the namespace. You can actually scale up you can actually scale out actually, since the updates are being written. So in the background, what happens is when we subscribe to the notifications on SNS topic, for example, they get written back to an internal queue for consumption. On the internal queue, we have consumers listening to any entries written in the queue. So we can scale out on the consumers. Let's say we ended up with 200K updates in the last 2 minutes. Now we need to, and that's the scale at which the data is growing. We can scale as consumers, and the more consumers you add, the faster you are ingesting. So yeah, that way you can scale better.
Right. Yeah. Of course, I was thinking from a point of view that if storage has to be used for that kind of environment, then there are moving parts, and we're just thinking about from an application development point of view that when that you integrate it with your application, is the system able? Can the application rely on that namespace then? I guess it's a long discussion, so I'll just stop here.
I'll just put it shortly, but it's not most of the applications, or at least the some that we have been checking out with customers they don't rely on. For example, like if you take a Weka file system, for example, like they don't scan the namespace incessantly on an object storage. That would wreak havoc on the object storage with the number of files they're trying to back up at the same time. They hold they have an internal, they have their own database where they have listing of all the files available. So they would only perform heads and gets. In that case, they are discovering new files that show up as and when they show up. So that's where making it eventually consistent, not strongly consistent, helps out. Like it will not wreak havoc on the application if the application move from like AWS and then switch back to Zenko, then move back to AWS again. The failover failback will look very seamless.